Hello, my name is Kernan Freire, and on behalf of my co-authors I'll be presenting our late-breaking work paper on tacit knowledge elicitation for shop floor workers with an intelligent assistant. Agile factories adapt their production lines depending on customer demand. As such, workers are constantly reconfiguring, fine-tuning and fixing the machines, a knowledge-intensive task. These factories work in shifts to enable 24-hour production, but because they are under a lot of pressure, documentation is poor and knowledge sharing difficult. Generally, knowledge sharing between workers is poorly facilitated, which means there are large disparities between workers regarding knowledge. Effective knowledge management leads to a higher organizational performance. Knowledge can be split into explicit knowledge, which can be easily verbalized, and tacit knowledge, which cannot. In manufacturing, sharing tacit knowledge leads to a higher task performance. Tacit knowledge is difficult to express and needs to be converted into explicit knowledge before it can be stored and shared at scale. Due to its high value, many methods have been developed to elicit it. However, they are typically resource-intensive, involving skilled interviewers and analysts. Even recent techniques that use assistance systems for sharing tacit knowledge still require human analysts in the process. We're developing an intelligent assistant that facilitates systematic reflection through dialogues, a technique shown to elicit tacit knowledge and promote continuous learning. The resulting reflections are processed using a large language model and stored in a knowledge graph for later sharing. An example of a reflective prompt is shown here. After completing a product batch, the intelligent assistant could ask the worker to reflect on how they contributed to the recent production performance. The recent production data, including machine performance and user inputs, are visualized to help as memory cues. This interaction would replace the existing post-batch or post-shift reports that workers are required to complete. The next steps include lab studies using a simulated production environment and in-situ user studies at the factories. Furthermore, we are exploring additional ways in which large language models can be integrated, such as generating follow-up, reflective prompts, and sharing previously collected knowledge. The primary goal of these studies is to measure the effect of using an intelligent assistant in combination with different memory cues on knowledge elicitation, learning, and user acceptance.